It's a World Cup semi-final. India, New Zealand. The 49th over. A wicket falls, and in the next few seconds, 25 million people are all watching the exact same moment on the exact same app. This is Hotstar, and this is how it held every one of them without so much as a stutter. Here's what makes live cricket the hardest thing on the internet to stream. It isn't the total number of people watching, it's that they all move together. For most of the match, people drift in and out, no problem. But the instant something happens, a wicket, a six, the last ball of a chase, everyone reacts at once. The ones who paused, unpause. The ones who'd flicked away come flooding back. Millions of phones in the same 2 or 3 seconds, all asking for the same live moment. That's not a smooth curve you can plan around gently. That's a wall. And a wall is a completely different engineering problem than a crowd. Let's put real numbers on it. That night in 2019, India, New Zealand, the semi final, Hotstar peaked at 25.3 million people watching at the very same instant. A world record for a live stream. And they went further. 4 years later, the 2023 World Cup final, 59 million. That is still the largest concurrent audience any streaming service has ever served, anywhere on earth. 59 million people, one video, the same few seconds. That's the job. Before we open it up, one thing that clears up half the confusion. Streaming a match involves four different players, and Hotstar is only one of them. First, the broadcaster, the people with cameras in the stadium. They capture the match and hand Hotstar a single feed. Hotstar doesn't film cricket, then Hotstar takes that one feed and does three things. It re encodes it into many qualities, it chops it into little chunks, and it decides which delivery network sends which chunk where. Third, the delivery networks, CDNs, companies with servers in every city, that actually push the video onto your phone. Hotstar directs them, but mostly doesn't own them. And fourth, you, your player on your phone, pulling chunks and playing them back. So, the thing Hotstar truly controls is the middle, turning one feed into millions of streams and choreographing who delivers what. That middle is the machine we're tearing down. Okay, the whole thing on one screen. Just follow the video. It starts at the stadium. One feed comes in. Hotstar's encoder turns that single feed into a ladder of qualities. Full HD at the top, down to something that survives a weak signal on a moving train. A packager chops each quality into short chunks, a few seconds apiece, and writes them to an origin server. From the origin, the chunks fan out to the delivery networks, several of them in parallel, which cache each chunk at the edge, close to you. Your player pulls chunks, picks the quality your network can handle, and plays. And wrapped around all of it, a concurrency service counting how many are watching right now, an autoscaler making sure the servers exist before the spike, and a controller that can shed load when it all gets scary. Plus the extras on the side, ads stitched into the stream, and a firehose of emojis flying back the other way. That's the map. Now let's open each piece. That one pipeline is really several separate machines, each solving a different hard problem. We'll open the ones that matter. The delivery machine, how one chunk reaches millions. The player, how your phone picks a quality. The counting machine, how they even know the number. The readiness machine, how you have the servers before the wicket, not after. And the survival machine, what you switch off when it's all too much. Plus two on the side, the ads and the emojis. Same four questions each time: what it does, what it's built from, how the parts combine, and what keeps it alive when the wicket falls. Machine 1, turning one feed into many. Your phone, my phone, someone's phone on a moving train, all on wildly different networks. You can't send everyone the same crisp, high quality video. The train would just buffer forever. So the first thing Hotstar does is transcode. Take the single incoming feed and re-encode it into a ladder of qualities, say 1080, 720, 480, and a low one for a bad signal. Same match, several versions, all produced in parallel. And there's a cost worth naming. All this encoding takes time, which is a big part of why your stream runs a few seconds, sometimes more, behind the live TV broadcast. Your neighbors tell you cheers, and then your phone catches up. Now, each of those quality streams gets chopped into chunks, short segments, usually a few seconds of video each. This is the small move that makes everything after it possible. Why chop it up? Because a chunk is a file, and a file can be cached. Instead of streaming one endless river to each person, Hotstar produces a steady sequence of small, identical files, and everyone at the same point in the match needs the exact same copy. The chunks land on an origin server. And here's a tidy detail. Hotstar separates traffic into what can be cached and what can't. The video chunks, the scorecard, the highlights, cacheable, served from the edge. Your login, your watch history, not cacheable, handled on a different path. Keeping them apart is what stops the personal stuff from clogging the pipe that serves everyone. This is the heart of the whole thing, the single trick that turns 25 million viewers from impossible into routine. Watch. A chunk, 3 seconds of video, gets copied once to a server near you. Not near you specifically, near your whole city. That's a CDN edge, a content delivery network, a fleet of servers spread across the map, whose entire job is to hold copies of popular files close to people. Now, the magic. Everyone in your city watching the match is at roughly the same live moment, so they all want the exact same chunk. The edge server hands that one cached copy to all of them. One chunk, cached once, served to a million phones, and Hotstar's own origin only had to produce it a single time. That's fan out. One write, a million reads. Same shape as a viral post, but for live video. And it's why the number that really matters isn't how many people are watching, it's how many different chunks you have to make, which is not many at all. One more layer because even that isn't enough. At 25 million, the sheer amount of data leaving those edge servers is staggering, on the order of 10 terabits every second. Back at the 2018 final, 10 million viewers already meant 5.7 terabits a second and a million requests a second. No single delivery network on earth has that much spare capacity lying around on the night of a final. So Hotstar doesn't use one. It uses several Akamai and others in parallel, and it books that capacity months in advance, like reserving seats in a stadium. Then, moment to moment, it watches which network is healthiest and routes chunks accordingly. So the fan out isn't one pipe, it's several giant pipes, reserved ahead of time, balanced live. Capacity and redundancy at the scale of a nation. Now flip to your side of the glass. Your player has a decision to make many times a minute. Which quality do I ask for next? It watches your network. Strong Wi Fi? Pull the 1080 chunks. Signal drops on the metro, quietly step down to 480 so the video keeps moving instead of freezing. This is adaptive bitrate. The stream bends to you chunk by chunk. It's why the picture goes soft for a second instead of stalling. But here's a subtle trap at scale. When the network recovers, say a whole stadium gets signal back at once, every player tries to jump back up to high quality at the same instant. Millions of simultaneous upgrade requests, a stampede the system didn't cause but has to survive. So the clever players add a pinch of randomness. Each waits a slightly different tiny moment before retrying. So the herd spreads out instead of arriving all together. Quick one, but it matters more than it looks. That 25 million watching number on your screen isn't just for show, it's the heartbeat the entire system scales on. Most systems scale on CPU. When the processors get busy, add machines. Hotstar learned that's too slow and too late for this. So instead, it watches concurrency directly, how many people are streaming right now, and how fast that number is climbing. The rate of climb is the early warning. When concurrency starts racing upward, that's the signal to add capacity before the servers are ever actually in trouble. Which brings us to the hardest constraint in the whole episode. The normal way to handle a spike is autoscaling. Detect load, automatically spin up more servers. For a slow building website, it's perfect. For a wicket, it's useless. Here's the timing. When you ask a cloud for a new server, it takes around 90 seconds just to boot up and become healthy. Then your application needs another 75 to warm up and start serving. Call it 2.5 minutes from I need more to it's actually helping. A wicket spike arrives in about 3 seconds. Do the maths. By the time your new servers are ready, the moment is long gone. The 6 is hit, the crowd has reacted, the flood came and went. Reacting to this spike is quite literally too late. You cannot autoscale your way out of it. So Hotstar flips it around. If you can't react to the spike, you have to be ready before it. And here's the gift. A cricket match is scheduled. You know almost exactly when 9 million people will show up because the toss is at a fixed time and the final over is roughly predictable. So they predict. Using years of past matches, they forecast tonight's peak and then pre-warm the entire fleet up to that peak before the match even starts. Not reactively, ahead of time. On top of the forecast, they hold a buffer, millions of viewers worth of spare capacity, just sitting there, ready. So a bigger than expected surge still has somewhere to land. And how do you trust the plan actually holds? You attack it yourself. Hotstar built a load testing tool. They call it Hulk that simulates an entire match. Millions of fake viewers push through the real delivery networks and the real servers before a single real fan turns up. They run game days, they break things on purpose, and they fix whatever breaks. So on the actual night, nothing is a surprise. But what if you're wrong? What if the surge is bigger than even the buffer? You don't get to crash 59 million people are watching. So Hotstar keeps a last line of defense. And it's ruthless in the best way. They call it panic mode. The idea? Decide in advance what actually matters and be willing to throw everything else overboard to protect it. Two things are sacred, the video playing and you being able to log in. That's it. That's the P0 priority 0. The stuff that must never break. Everything else is negotiable. Recommendations of the continue watching row, of the personalized home screen, the live chat, the flying emojis, how often the scorecard refreshes, dialed down or switched off completely. Under extreme load, the app deliberately gets dumber so that the one thing you actually came for, the match playing smoothly, keeps working. It's a lifeboat drill. You already know what you're saving before the water comes in. Now, my favorite because it flows the other way. Everything so far has been video going out. But in a big moment, fans send something back. They mash the emoji button. During the 2019 World Cup, they sent 5 billion emojis. Not a typo. 5 billion little bursts of feeling. And Hotstar shows a live read of the crowd's mood right on screen. Think about that shape. Millions of people, each tapping a few times a second, all at once. You cannot handle each tap as its own message. You drown instantly. So watch how they tame it. The taps hit lightweight collectors, small services written in Go that don't really process anything. They just gather taps into batches. Every couple of seconds, a batch is dumped into Kafka, a big durable log. Then Spark reads that log in little time boxed windows, micro batches. And instead of user A sent a laugh, user B sent a laugh, It aggregates. In the last 2 seconds, this region sent 400,000 laughs. One number instead of 400,000 messages. Finally, that little summary is pushed out over a pub sub layer, a broker built to hold millions of live connections open at once, and your phone lights up with the mood of the whole country. Collect, batch, aggregate, broadcast. That's how you turn a fire hose into a feeling. One more quickly, because it's sneakier than you'd think. A cricket match carries over 100 ad breaks, close to an hour of ads across a game. On TV, that's trivial. In a personalized stream at this scale, it's a real engineering problem. Hotstar stitches ads directly into the video stream on the server side before it ever reaches you, so there's no separate ad player to stall, and an ad blocker can't simply skip past it. The stream just cuts to the ad and back seamlessly. But stitching a different ad for every single viewer would blow up the whole cached chunk trick we just built. So instead, they group viewers into cohorts, buckets of similar people, and stitch one version per cohort. A few thousand ad streams instead of 59 million. Personal enough to be useful, shared enough to still cache. So here's the whole episode in one sentence. A wicket falls, and in 3 seconds, tens of millions of people all want the exact same moment at the exact same instant. Everything Hotstar built is an answer to that single sentence. When 25 million people arrive in 3 seconds, what actually breaks first? Not the video. The video is the easy part now, it's just cached chunks fanned out. What breaks first is everything personal and shared: the login servers, the recommendation engine, the databases holding your session and your history. The things that can't be a cached copy because they're about you, which is exactly why the design is the way it is. 4 moves and you've seen everyone. 1. Fan the video out from cached chunks so the hard part serves millions cheaply. 2. Don't react to the spike, predict it and pre provision because reacting is too slow. 3. Prove it holds by attacking yourself with load tests at real scale. And 4. When it's still not enough, shed everything that isn't the match and protect the two things that are. Cache what's shared, pre build for the known spike, test to destruction, and know what to sacrifice. That's how you hold a whole country on one video. So back to that wicket. In the 49th over, 2019, 25 million people saw it fall at the same instant, and the app didn't so much as stutter. Not because Hotstar had one giant server, but because it had one cached chunk copied to every city, delivered by a fleet of networks it booked months ahead, running on servers it had pre warmed before anyone arrived, guarded by a panic switch it hoped never to flip. The lesson isn't throw money at servers, it's that the right few ideas, cache the shared thing, predict the known spike, and decide in advance what you'd protect at all costs. Turn an impossible wall of people into a quiet Tuesday. Hotstar's wall is millions all wanting to read the same thing. But what about millions all trying to grab something where there are only a few and most of them have to lose? That's 10 in the morning on the Tatkal counter. That's IRCTC next time.